Hello, my name is Vitaly Rudnitsky. I'm the host of Data and Analytic week of Devtoberfest. Before we start with our session, I just would like to quickly introduce you to the program of this week. Starting this week is the Demystifying Data Science in Enterprise. And our colleagues from Deep Learning Center of Excellence in Waldorf, Manuel, Zeise, and Stefan Baur, will remove the mystery behind data science. Later today, you can join as well the Modern Enterprise Data Landscape session. And it will be presented by no one else but Alan Simon, who is the author of best-selling data warehousing and data lakes books and courses. There will be one more presentation during this week presented by myself on November 4th, and the topic will be data visualization. Besides regular presentations, we have as well a few interesting and engaging panels for you. Two will be during Wednesday, so tomorrow, where you will have two chances to meet authors of books on the topic of SAP data and analytics, one during our, let's say, European and Asian time zone, and another one during Europe evening and suitable for America's time zone. If you have any questions that you would like to ask our experts about data science in practice, not that much about products and features, but more about how to run projects and how they look like in the real life, then please join us on November 1st. As always, we have some ways for you to get more points for those of you who are participating in collecting points and badges in our Devtoberfest game. We prepared a set of tutorials that completing these tutorials will give you some points, but as well as every week before, we have a coding challenge where you can apply or maybe learn, if you haven't tried it yet, some SAP HANA multimodal capabilities. And then, as always, we finish week with some Fun Friday activity. And this Friday, we will be talking about coding for kids. There will be, again, two sessions. Depending on your time zone, you are more than welcome to join one or both of them. And our SAP colleagues who are working on the programming language for kids that is called Snap will present how this language is built, how it is maintained, what are the educational principles behind it, and then as well, they will share some fun projects built using this environment. So as you can see, the agenda for the week is really packed, but now it is time for us to dig into demystifying data science in enterprise. Manuel, Stefan, the stage is yours.
Thank you very much, Vitaly. So welcome to our session. Data science is really a hot topic, and to be honest, whenever you tell people that they are data scientists doing AI, they ask you, okay, how does it look like when you work at SAP, when you have this bunch of data scientists in a group? Are you developing an AI like, I don't know, in Minority Report or maybe Skynet in Terminator? And well, to cut it short, no, we don't. But since this talk is about demystification, let me show what you might see when you happen to enter our offices during a coffee break. And it's this, a big screen on the wall running Mario Kart 64. In case you never heard it, Mario Kart 64 is a go-kart racing video game by Nintendo, and it features characters from the Mario universe like Super Mario, Yoshi, or Donkey Kong. And in case you don't believe me, here's photo proof. 3 data scientists, one being me, racing under the supervision of a colleague, because we only have 3 controllers. And obviously, we do have superior driving skills. What else? But as data scientists, we also have a tendency to make use of any data that is generated and available. And in this case, we started recording each game constellation and the result of each game. And based on this, we can run analysis, starting with the obvious question, who is the best player in the team? You can see here myself and a colleague discussing this question. And just a quick question to you. How would you calculate a fair ranking? But before you answer, like in enterprise context, we also have a number of constraints. Here's what we have. As said, we have 6 players, and as said, we have only 3 gamepads. And players might be unavailable because colleagues are working remotely from home or at the customer side. So they are not available at all times. Of course, we also have colleagues joining us in the coffee break. They should be considered in the ranking as well. So a fixed tournament schedule that's clear is not possible. And what could we do then? Well, in a normal setting, I would now ask you to shout out some ideas. That's not possible in this virtual ranking, so a virtual setting. So I collected some ideas that usually people come up with. So first of all, let's do it like in Formula 1. So first player gets 12 points, second player gets 10 points, etc. But if you think about it, it's sounds nice, but it does not really work because the more races you finish, the higher your score will be. So players with limited availability to participate in races have a disadvantage over the colleagues who are always in the office and can play a lot of games. Now you say, okay, maybe that's not a good idea. Maybe let's somehow average the finishing position of each player. But then if you think about guest players, you might have problems because if there's a colleague joining for 2 games, being lucky, winning both games, he will never show up again because, he's in first position and he can only lose when he plays another game. So that's also not a good solution. And the same is if you now say, okay, let's calculate the average number of wins per player. You have similar problems. So you see, it's not that simple. We have 3 approaches already and neither of them is satisfying. And the problem seems less trivial the longer you think about it because of the constraints. And the same is true for many data science problems in business contexts. The business processes, so the way how companies operate, usually give you some side rails or even hard constraints on what is feasible or not. And as a data scientist, you have to adapt to that and still find an optimal solution under these constraints. And yeah, how did we do it here? Did we came up with a groundbreaking new algorithm? Well, no. We applied Microsoft's TrueScale algorithm. It's an algorithm Microsoft published a couple of years ago in a paper, and they use it for matchmaking and high score ranking in the Xbox universe. So when you ever played Halo on an Xbox, you were experiencing the TrueScale algorithm. And it's following some Bayesian approach to estimate the strengths of a player or the skill of a player by using 2 indicators. One is like the average skill, mu, and the other one is the uncertainty of the skill estimation. And in a very hand-waving explanation, the more games you play, the smaller your uncertainty gets in the skill estimation. And if you win or you lose in a game, your average skill will go up or down. The amount, how much you go up or how much you go down, obviously depends on the strength, the average skill, and the uncertainty of your opponents. And in that case, we were lucky. We didn't even have to implement it on our own. We could use the Python implementation of the algorithm that you find under trueskill.org. And we could build our analysis pipeline with the game constellation and ranking results as an input and the player statistics at the output. And I know what you're thinking right now. Data scientists are obviously lazy. Well, to be honest, we prefer the term efficient, because if there's a state-of-the-art technique or even a tool that has been implemented and tested, we are not going to reinvent the wheel. We are going to use it because that's much cheaper and much faster. Of course, if this is not the case, because we have constraints that are not fulfilled by the approaches that are so far known in the public, then of course we come up with smart new solutions. But otherwise, we stick to what has been proven to be successful. And here are the results. On the left, you can see the player rating over the number of games. Higher rating means better driving skills. You see there are clear differences between the players. I cannot tell you any names, unfortunately, but I can tell you one thing. The gray line that you see at the bottom, that's a manager. It's not a data scientist, it's a manager. And on the right side, you can see the rating per character. So instead of looking at the players, we're now looking at the characters in the game. And since we had a random assignment of characters to players, which was a conscious decision in the beginning that we made, we could do this measurement of the strengths of the different characters. And this is, by the way, also typical for data science. We try to get more information out of the data. And if we can do slight changes to the collection process, of course, we will go for it. And if there's one and only one takeaway from this whole presentation, it should probably be this. If you're playing Mario Kart 64, go for Wario or any other character, but never choose Luigi. Never Luigi. Data science has proven Luigi is really a bad character to win games in Mario Kart 64. And to summarize this kind of casual introduction, I hope you don't miss the hype cycles or quotes that you usually see in introductions about data science. For us, like we've seen in the past that like data science is really everywhere, where you have data and complex questions. And questions that appear simple are usually in reality quite complex as soon as you have some constraints. And as data scientists, we solve these challenges with like ingenuity and of course pragmatism, as you've seen before. But now, coming from the coffee breaks to our everyday work, and from data science, which comprises statistics, optimization, and machine learning, we will now come to only machine learning, where we use trainable algorithms to make all kinds of predictions. So this includes like deep learning, but also traditional methods, like random forests or linear regressions even. And first of all, here it's important to make a difference between data science approaches and standard software development. You know, like normally software development is a linear process. You define requirements and then you implement. And nowadays, of course, you do it usually in some agile approach, like following Scrum, but still you always have a clear idea what the result will look like. And machine learning, however, involves much more uncertainty. And this is why we need an iterative approach. And it all starts with like the definition of the business problem. And here we as data scientists sit down together with the stakeholders and business experts and discuss their problem or their desire to, what they want to do with machine learning. And the first question for us is, do they really need machine learning? If you have a task that takes like one employee 5 minutes a week for this task, it's not worth training a machine learning model for that. That would be too expensive regarding the benefit that you would get. But if you have a highly repetitive task that can be automated, such as like a product recommendation, then that's a good candidate for machine learning. In general, as soon as you have like complex rules and some unstructured data, it's worth thinking about machine learning. But after you define the problem together with the experts, you also have to define some success criteria. That is often overlooked. So success criteria means like the guiding question is here, how do you decide whether a model should go into production or not? For us as data scientists, I mean, it's easy. We have a lot of metrics that we can use to evaluate the usefulness of a model: accuracy, cross entropy, mean absolute error. I mean, there's so many. But stakeholders do not understand these metrics. They are not into statistics or machine learning, so they can't use it. So the evaluation of our models has to be aligned with their way of thinking, with their business goals. And you have to show that there is a clear business value if you implement a machine learning model. And if you want to know what could it be in reality, well, if you think about sales forecasts, it could be the precision that you achieve. Or if you want to identify fraud cases, it would be the expected number of additionally identified fraud cases, or increased revenue, improved margin. There are so many, and as you see, they're all related to business. Now, another thing that you should do in this kind of ideation process is thinking about baseline models. That's what we call hypothesis generation. So when you train a machine learning model, of course, you have to know whether you are like whether this is a reasonable result or if it's just randomly guessing. And for that, you need a baseline model, a simple algorithm, just like somehow doing smart guesses. So when you do a sales forecast for the next week, the sales numbers from the last week might be a good baseline model. But discussing it with the experts, you might also come to the conclusion maybe the numbers from the planning department are a good baseline model, because you want to improve on top of that. So, but that's kind of this part of this discussion process. During these, when you talk to these domain experts and stakeholders, of course, what you also try to do is explain that a model will always make some predictions wrong. You will never have a machine learning model that achieves 100% accuracy, and that's very important to communicate that, because sometimes you have like really business experts that have no idea about machine learning or statistics, and then they expect, okay, machines can do everything perfectly, but in that case, it's not like this. Then, of course, as soon as you're aware of what you want to do, you can start collecting the data and preparing it. In enterprise context, usually your data is distributed across multiple systems. Maybe some are SAP systems, others are maybe external systems, and you have to join this data. You have to export it, so usually as a CSV file. And as a data scientist in this step, you're performing an exploratory data analysis. So you try to understand the data and get a feeling for it. You try to, for example, identify the meaning of flags or other features that you find in the data, and you talk to the domain experts, but also to the data experts that help you with the export to get this understanding of the data. And there might also be filters that you have to apply to get either a reasonable subset or like meaningful results in general. So when you do a propensity to buy prediction, you might only focus on loyalty, customers taking part in your loyalty program. So you have to find the flag that indicates these customers. And as soon as you have done that, don't worry, since it will be a loop, we will come back to this point again. But if you have done this in the first step, then you can think about finding a suitable model. And this is exactly what you saw before in the Mario Kart example, where we thought, how can we solve this problem? And back then we used the true scale algorithm. Now, of course, in our case with real world projects, we decide whether we want to go for a traditional approach with like random forest or linear regression, or if we need a neural network with like deep learning approaches, etc. This is like the decision that we do in this prototyping step. And of course, as soon as we made this decision, we train the model using the data that we just exported to tune the parameters in the model, maybe also tune the hyperparameters of the model itself, like the architecture, or if you think about random forest, how deep your trees grow, etc. And as soon as we have that, well, of course, we can evaluate the model quality. Here, since we, of course, we can calculate our data science metrics such as accuracy or cross entropy. But of course, we also calculate like the business metrics that we need for the success criteria that we discussed in the first step. And we use that to communicate the results to the stakeholders. And you see here, we are closing the loop. And we explain the results. We explain, of course, also the model approach in like a simplified terms, of course, because stakeholders do not really know what a random forest is. But if you kind of simplify it, you can even explain it to non-experts. And you also tell them more what you found out when looking at the data. And from our experience, you go through this cycle multiple times. What I've seen in the past over and over again, whenever you talk to the domain experts, because you go through this cycle, they will have some new ideas. They will have new hints that you can use in making your model even better or more accurate. Like in the next cycle, you might use additional data sources, like hierarchy information that you have usually in data. When you have like customers or materials, they have in an SAP system or other systems, they have some hierarchy information connected to it, giving you more information about the customer or the material. And that can be very useful in an analysis. But you also discuss like important features that you found. And here a common pattern that we have seen in the past is that there are some technical flags in the data that are not recognizable as technical flags in the beginning that are contributing very much to the model prediction. So when you've seen in the past maybe a material master data in an SAP system, it's the Amara table. Then there are like fields like PSTAT or VPSTA, which describe the maintenance status of a material, or LFORM, which is like a marked for deletion flag. These fields are surprisingly good in predicting stuff, because regardless of what you predict, whether it's the affinity for customers to materials, or if it's the delivery time for material, or master data properties, they always come up among the, like, I don't know, 10 most important features. But you can't use them. They are leaking information usually, because they tell you stuff that you should usually not know, because they are filled afterwards or in hindsight, and then you can't use them. Like if you want to predict, I mean, end of life, there's already this marked for deletion flag set. Yeah, I mean, of course, it's likely that it will go into end of life soon. Because there was like this decision made by the business. And only if you explain that to the stakeholders, they had the opportunity to tell you, no, you should not use that, or have you thought about using that, etc. Or they even tell you about a new aspect of the business process that you haven't been aware of. That also happened a lot of time. And in rare cases, it can also happen when you present the results of your first models, that you come to a point where you rephrase the problem or the question. So you have a defined business, the business question, and now you rephrase it. To give you an example, once we were asked to predict the delivery times for goods at a discrete manufacturer. But it turned out that the prediction of the exact delivery time is very challenging, or basically also not useful, because if you have like a delivery time of 5 days on average, and you have an uncertainty of 3 days with your model, you can't really use them. But we also learned in the discussions with the business experts that they are basically only interested whether the goods will be delayed or if they will arrive in time. So together with the business, we rephrased the problem from a regression task on the delivery time to a classification task telling us whether a delivery will be delayed or not, and which could be done, as it turned out, with a much higher accuracy, and as a consequence with a much higher business value than the original question of predicting the delivery time. Now, if you go through the circle, the loop once or twice, at some point you come to a point where you say, where you decide together with the business that the success criteria are met, that you can productize the model. Of course, as a data scientist, we are not experts in that. So software engineers come into the game. They know how to run a service in a productive environment. They take care of the process integration. They build a UI. They take care of authentication, logging, etc. But still, data scientists are needed in this step. First of all, we have to define a feedback loop for the data. So when we make a prediction, like for the delivery time, of course, at some point, we want to see in reality if this actually worked out. So we need the actual delivery time and have this as a feedback loop. Or if we predict the affinity for products to customers, then of course we have to check after like 6 months whether the customer actually bought the product, or if we predict some master data properties, then of course we are interested in whether the humans actually corrected the information, and that we might need for training a new model. And also, like another aspect to it is, of course, like the life cycle management. We need to define when the model needs to be retrained. So there are models that you only have to retrain like once a year, or when you see a degradation. Other models might be retrained every week. That's a decision that we usually find together with the business experts, because they know more how often the underlying data actually changes. And related to that, of course, we also have to track relevant metrics to ensure that the model is still working well. So that's, as said, the feedback, evaluating the feedback loop, but that also starts earlier when we look at the input data. So we might identify shifts in distributions of the input data. So instead of having just only average customers, maybe now we have younger customers, and for them some properties are different. They might have less often credit cards or something like that, and if our model relies strongly on credit cards and not other aspects or characteristics of the customers, the precision might degrade, and that we have to detect as well. Of course, even if we put the model into production, it can happen that we continue this cycle of discussing the current status with the experts, also what maybe feedback from customers or from users have been collected, and then improve our models and push a new model, an improved model into production. And while this whole process or this whole cycle really looks like the product, to be honest, of a consulting company or just a copy of a textbook, I can assure you this cycle captures our working mode really, really well. And we have a number of machine learning-based business services running, ranging from named entity recognition to document information extraction, to extract information like from scanned invoices, emails, or other business documents. And we have successfully followed this cycle for all our projects in the past. Of course, not all of them go into the productization, but all the successful projects really followed this cycle. And my colleague Stefan will now give you more insights into our work on one of these business services that we have live that our customers can use, and then that we implemented like this. And this is the generic line item matching. And with that, Stefan, stage is yours.
Okay, thank you, Manuel. 1 second. Okay, yeah. So so in this case study, I will describe one of our projects, and I think it captures some of these aspects that Manuel mentioned quite well. This is the area of matching of business documents. So the use case that got us started in this area was in accounts receivables, but now we took this technology and we were able to branch out and also enable adjacent use cases with the same technology, like similar kind of matching use cases. And so what is accounts receivable about? So a company sends out invoices to their customers, and they return, they get payments, and these payments need to be reconciled with the invoices that they send out to their customers. And matching bank statements to invoices is a process that requires a lot of manual effort, even though you can automate part of it with rules, right? You can define rules like, is the invoice number in the memo line, and is the amount and currency identical? And then I can, say maybe I can automatically clear this kind of pair. But in practice, there is a lot of complications. For example, one payment might pay multiple invoices at the same time. There's different formats for memo lines and so on. And this prevents you from reaching a very high degree of automation. And where machine learning comes in is you can now train a machine learning model and try to increase that automation rate from the rules to a higher degree, and also speed up the kind of the business process itself. And so in the next slide, I will describe, so why is this a good use case for artificial intelligence or machine learning? So the first point is rules fail. So you can only automate part of the process using rules, right? Because the data is very variable. It depends on countries, country specifics, business process specifics, and so on. But at the same time, there is high quality data available, basically the historical data from the past clearings that were manually cleared by the accountants. And this is already available on many customer systems. Finally, there is a clear business value. So the business value is you can increase the automation rate that previously had to be done manually. And in addition to that, you can also speed up the manual process by proposing to the accountant the potential optimal matches. But now let's take one step back and think about, enterprise AI use cases, sort of what kind of categories are there? So I would say there is 2 broad categories of use cases, and they, even though they overlap to some degree, they require slightly different approaches. So the first case is when you have a universal model. So you have one proprietary data set that is maintained by your data science team or AI team, and you train a global model that solves a particular universal task. One example for that would be OCR, right? Recognizing characters is universal across customers, and you can serve many customers with the same approach. Another example would be what Manuel already mentioned, extracting entities from business documents. Business documents like invoices, there is different layouts, but the task itself is still universal across customers. And here, if you have a sufficiently large annotated data set, you can sort of construct this global model and it will scale really well across customers. On the other hand, in some cases, for example, think those examples that Manuel gave about delivery time, predicting delivery time. This is very data set specific. Yeah? So it will require, I mean, it will be very different for different customers or different data sets. And so in these cases where the data is customer specific or it depends on the customer's implementation of the business process, you need to train models on the customer data itself. And so in this case, you would train one model or maybe more than one model for each customer and then serve this model to the customer as well. Another reason why you might want to go in with a retrainable approach is that you have technical or legal reasons that prohibit you from training a model on, say, all the customer's data and then serving it to another customer, for example, or train a model on one customer's data and then serve it to another customer. You need to be able to obtain clean historical or manually annotated data from the customer in this case. If it's manual, it will require a lot of effort. But also hybrid approaches are common. So sometimes you have a global model, you can serve several customers with that global model, but for some customers, you need some kind of customization, and then you could further fine-tune this model, right? So this also exists. There's no clear-cut separation. But the accounts receivable use case, because of that customer specificities and so on, is in the retrainable category. So the development process is also a bit different in these two cases. So in the first case, the AI experts develop and ship a pre-trained model based on this proprietary data set. But this means also that once you ship it, it can be used a lot like any other kind of software, right? So you get an OCR package and it basically takes a PDF document and then extracts text from it. So it's in a way a lot like a regular software. But a retrainable service is a bit different in the sense that now the AI experts don't ship the model itself, they ship the code to train the model and evaluate it and so on. And it requires orchestration. So a lot of engineering effort. So the customer needs to be able to upload the data. You need to be automatically validate and train the model and also do some benchmarking to kind of tell, okay, does this approach actually work well on this customer data set? You need model storage, versioning, and also monitoring of business metrics. And you need to have some framework to activate and deploy the models. And when you, as a data scientist, develop a model like this, you, of course, need to evaluate it on many customer data sets before to make sure the approach actually works. So for Cash App or our accounts receivable solution, the machine learning workflow looks something like this. In the first step, the application extracts the historical data from the customer system, for example, from the cloud or on-premise ERP system, and then training is triggered. In the cloud, the data is split into training, validation, and test set, and a model is trained on the training set. And on the validation set, we do some kind of calibration, to map model confidences to expected accuracies, and also to tell the customer essentially, if I want a particular target accuracy for my predictions, what fraction can I automate or propose? So this is this proposal rate. And at the end, we evaluate this calibration once more on a separate test set to validate the expected accuracies. And then this report gives the customer the expected performance in production. Later on, at inference time, the application sends data to the cloud to do the reconciliation, and an inference job is triggered, which deploys the matching model, and then this inference job produces predictions for the bank statements. For example, okay, it says bank statement 1 matches to invoice number 15, and it also assigns a confidence, like how confident the machine learning model is to this prediction. Afterwards, the predictions are returned to the customer, and some of them, which are very high, where the confidence is quite high, might be cleared automatically. So this is the additional automation. But some the customer might review, the accountant might review, and even in rare cases, sometimes they're also incorrect because machine learning is not a technique that solves problems typically like 100%, like like in a deterministic way, but there might also be a small chance for errors. And so this brings me also like to how we evolve the models. So this is also shown by Manuel, right? So he says we have this this workflow where we develop a model, but we also might come back to the same point later in time. So so how did we approach this problem? So the first generation was that we do something simple inspired by the rules. So we say, okay, let's engineer a bunch of pairwise features to predict which bank statements and invoices might match the best. So for example, an engineered feature could be something like, is the invoice number contained in the memo line? Are the amounts matching, and so on? And then these engineered numeric features are given to a classifier, and this classifier was tree-based or decision tree-based. So we used the gradient boosting approach, and this was the first generation. Then the technology evolved, and the deep learning essentially came along, and we saw, okay, maybe we can use a different approach that gets rid of this feature engineering, and maybe automatically learns the pairwise relation between the fields. Yeah, and so we did a proof of concept, our team, using this deep learning approach, and we found that okay, it actually does solve this problem. So we don't need to do feature engineering anymore, and we also get improved business metrics consistently across customers. And so this was really like a big step for us. And we took this then and that, okay, but now that we have the solution that you don't need to do feature engineering anymore, can we enable maybe other use cases as well? And this is how we started with a generic line item matcher, or GLIM. So we carve out the generic component using the know-how gain from the Cash App use case, and we productize this deep learning model initially in Cash App. And then now we are enabling adjacent use cases with the same technology. And this summarizes the approach in one slide. So it's like a general approach applicable to when you have the problem of matching sort of two different tables together, or line items from different tables. You have this can be any type of tabular data. I mean, I will show like some examples later, what other use cases we enabled. It's reusable. It's a library and a service. So in the library is what our team develops, and the service is sort of what other use cases can sort of build on. And one big advantage is that it now makes it more efficient to more quickly enable other use cases, essentially. So what cast does this solve? So at training time, you have a table with query items, think bank statements. You have a table with target items. You can think of them as invoices. And you have a table with historical matches. So this is what the accountant, for example, manually cleared in the past. And you have a schemas and configuration, which is which features can you use for this to train this machine learning model. And here you have to be really careful. Like as Manuel said, sometimes you specify a feature which is contained in the training set, but it's not available at inference time. And sometimes this is very difficult to tell because the data you see when you develop the model is typically the training data set. So this is what's extracted after for example, the clearing happened in the system. So you cannot easily tell from the training set which features are available at inference time and which not. But this is something where you have to be very careful. And then once you do this, you get a trained model and metrics out of this training process. And then later at inference time, the task looks quite similar, right? So you have a table of query items, a table of target items, but you don't have, of course, the historical matches because this is what the model will reconstruct. And so what this model does, it takes all pairs allowed by, okay, there's typically some simple rules, so not all items from the query table would be relevant to the items from the target table, but according to rules, there is always like a set of valid candidates, and all these candidates are scored by the model, and it gives a score for each pair, so like a confidence score. And this tells you, okay, is this pair of items matching or not? And then you also, in addition to that, get explanations to understand why the models made this decision. So, and the explanations are typically in some kind of pairwise format. So here, for example, the memo line and the org name. So this means the model probably based its decision on that the memo line had a match with the organization name on the invoice side, and so on. And so these kind of explanations help you to understand, yeah, why the model made the decisions it made. And so now this brings me to our reusage scenarios. So Cash App is what I now talked about, the accounts receivable use case. It's about matching invoices to inbound payments, also to automatically clear high confidence proposals, so increase automation, and obtain recommendations for manual clearing to speed up the manual process. But now we are also enabling intercompany or intelligent intercompany reconciliation. This use case is about corporate groups. So the parent company and subsidiaries that kind of trade among each other. And at the end of some accounting cycle, you need to identify groups of line items that belong to the same transactions to kind of eliminate them. And this is one use case that we just going live with or went live with. And there's also a tech session on this if you want to learn more about it on November 18. In addition to this use case, which we are enabling on Chilem, we also have another use case called returnable packaging management. So this use case is also a matching use case that's about companies shipping products in some kind of expensive packaging. For example, think racks racks for engines or something like this. Or here in this pictorial example, it's a crate of wine, and you want the crate back to get back the crate after delivery to reuse it. And here you need to match the posting document to the inbound statement of record for the returnable packaging. And this is also a task that requires a lot of manual labor, and using machine learning, you can accelerate it. And there's also a session in TechEd on November 17 on this use case. So what is the architecture? Currently, we have the Chilem library developed by the data science team. This Chilem library contains the core machine learning approach, so training and inference and so on. And we productized it in Cash App, kind of we integrated directly the library into the product. This is how it's already live with several customers. But at the same time, to more quickly enable new use cases, we also developed a Chilem service, which does a lot of this orchestration I talked about, and it incorporates the Chilem library, as its core. But in addition to it does also the things like scheduling training jobs, scheduling inference jobs, and so on. And this enables the intelligent ICR service and the returnable packaging management. And currently, the service is only available for internal use, so it's internal products like ICR and RPM who build upon it, and then external applications would kind of directly communicate with the different applications. Okay, and so what is the collaboration mode between the data science and the engineering team? So as I said, right, this requires actually a lot of engineering. In fact, most of it is engineering in a way. So what do the data scientists do? The data scientists develop here in Chip a Python library we use for model training and inference. We have a clear interface to the product code base, which is really important because otherwise it's difficult to smoothly integrate. We do research on machine learning topics and features. So how can we improve the model? We add explainable AI features. We think, okay, what are the new directions for the AI approach that we can take? Maybe there's new ideas coming up and so on in the literature, and we incorporate them. We also incorporate customer feedback related to machine learning. For example, customers might tell us, okay, here the predictions don't work, and we investigate and figure out what could be going wrong. And this has in many cycles also improved our product a lot. Then the engineering product team is really responsible for the product. So they release the product, maintain the backlog. They're responsible for things like security, authentication, logging, UI that's facing the customer, model and data lifecycle management. For example, triggering new trainings and so on, retrainings. Integrating the Python libraries that we develop into their product. This is a Chilem service and Cash App essentially. And also they have the subject matter experts for the business process that we also consult with to understand, okay, what what constraints from the business project process can be incorporated to improve our product. Okay, and so with this, I'm finished with a case study. I will hand back to Manuel. We'll now talk about recent trends in AI and machine learning.
Thank you, Stefan. Yeah, like in every field, like also in data science, there are trends that emerge over time. And we would like to talk about two of them, ethics and explainability. But as before, we try to give you the real world perspective, not just like the textbook perspective, to give you an idea how it matters for our daily work, how we apply it. And you've seen it with the explainable AI already. Stefan mentioned it in the generic line item matcher case. Now, the situation usually is the same for all projects that we have with respect to explainable AI, that business users in the beginning do not trust new machine learning models. And which is natural. I mean, we share this feeling as data scientists. We also do not trust our model in the first round. We have to gain some trust. And but for like non-experts, it's really difficult, especially if you have like unexpected predictions. Usually like wrong predictions. And I can tell you some funny anecdote. We were once doing a master data completion project with a customer, and we did the result analysis with the business experts. So there were really like 10, 15 experienced experts doing master data quality for like 20 years, sitting in one room. And we were presenting results on the screen, and suddenly we had this unexpected result. And it was so unexpected that even we as non-experts, we could say, okay, this for this material, based on the material text, the prediction is wrong. But we were lucky we had explanations for each individual decision, and we could show why the model came to this conclusion. And in the end, it was a problem in the underlying master data for this very specific article. And as soon as the business experts, of course, fixed the master data, the prediction was then okay. But what was more important even than that, the business experts understood that the model is not just randomly guessing, but doing reasonable decisions, that they can get a feeling what is it doing. And this really increases the trust on the user side. Of course, for us as data scientists, there's also like this debugging aspect that we try to identify like information leakage or just understand what are important features to go into the discussion with the stakeholders. There are, of course, different approaches for explanations. There's like feature attribution, explaining, okay, this feature is important for this decision, or this is kind of pushing the score up or down. And then there are like counterfactuals where you really say, okay, it's this invoice and not the other invoice because of A, B, C, or like contrastive explanations, as you can see it in the example on the right side, which is a draft for a typical visualization of a machine learning algorithm, where it says that the delivery takes longer than on average. You can also see it with bar charts. There are different approaches. It depends on the use case. Sometimes we can use libraries like Shep or Lime. Sometimes we need custom approaches. But of course, as soon as it goes to the end user, we need an appropriate visualization. And Stefan mentioned it multiple times for the generic line item matcher there. We actually say, okay, we think it's a match because these two features have some similarity or have some important influence on the result. So this is really important. We try to do it all the time, even if we don't expose it to the end users. And the other question is ethics in AI, or as a friend called it, weapon of mass destruction. There are two aspects for it. And maybe you have heard about this issue of ethics in AI. There were a lot of scandals for machine learning models doing, let's say, questionable predictions depending on what you feed into it. And to avoid that, basically, there are like two things to keep, two aspects. One is a moral compass. Of course, you should have it. We at SAP, I think we have it. We try to, we always design our models for people and based on values. And that means we try, for example, to overcome existing biases. So if you train a machine learning model to for an HR use case, you try not to replicate the same flaws that you had in the human decision process, excluding the wrong candidates because of certain characteristics. You try to avoid that and implement measures to the balancing this. But even if you, assuming you don't have this moral compass, there's also data science perspective to it, because any bias that you have in your model leads to unexpected results, and unexpected results is maybe a bit too vague. I mean, it's really wrong results. If you have deviations in your input distributions, your results are not credible anymore. So you have to detect these deviations, and in order to take care that you do not introduce biases because of the selection of your training data, you should really always run like A/B tests on real-world data, maybe in parallel to your existing process, testing it before implementing it. Of course, as a big company like SAP, we not only have a commitment, but we also have like a structure in place to support this ethical way of developing machine learning models. We have an advisory board and a steering committee for ethics that also develop like guidelines that to teach data science, or to raise awareness among data scientists, what could be pitfalls, so that when we train models, of course, we are usually in this business context, but even there, try to avoid biases that we might introduce accidentally. Now, with these two trends, let's come to basically some final thoughts. When we look at our successful AI applications, and the generic line item matching is for sure one of these successful applications, we always see that they support humans. They extend their possibilities. They get rid of dull tasks and enable them to do more reasonable tasks. And these AI applications usually mediate between the analog world, where you have paper documents, scanned invoices, images, etc., and the digital world, where you have entities in IT systems that you can process automatically. And if we look at data science, I mean, I showed you the methodology that we follow. So we try to do this in the scientific approach, where we experiment, we evaluate, and then reconsider our decisions. We go for pragmatic solutions, because in enterprise context, we also have to look at the costs. And I hope we could also show you that this is not like a work that we can do as data scientists alone, but we work together with business experts, domain experts, and data experts, and of course, software engineers to put it into production. And of course, last but not least, to be honest, it's also a lot of fun to work as a data scientist. And I think Stefan agrees to that. And with that, we'd like to thank you for your attention. And Vitaly, I think we can now come to the Q&A if there are any questions in the chat.
Sure. Thank you, Manuel. Thank you, Stefan. It was interesting for me because, frankly speaking, even though I am more of the data engineer in my background, I am going through this machine learning course on Coursera right now, right? So I could compare something that I'm learning in theory with what you and your team are doing in real life. And while we do not have any questions in chat yet, and everyone watching, please just ask your questions and I will read them to our presenters. I will take just this chance and ask my questions. Hopefully they will help me as well to get better final result in machine learning course. First question that is very, very often in general is, where in this cycle of working on machine learning project do you spend most of your time?
Good question. Stefan, would you like to take it, or should I take it?
Maybe we can both say something on this. Yeah. Okay. Where do we spend the most time?
So is it gathering business requirements? Is it collecting and cleaning data? Is it training, retraining the model?
I would say in the first cycle, it's for sure preparing the data and cleaning the data and finding getting an understanding of the data and finding the right selection criteria. As soon as you are like in the second or third cycle of the loop, then of course you spend more time on the on like actually developing the model and trying different approaches, doing studies, what gives better results. I think then it like kind of shifts, because like the data preparation, you try to automate then, or to run a pipeline, build a pipeline for this. So that decreases afterwards. But in the beginning, like in the first cycle, it's really like this data preparation. And you should always never underestimate also the time that you need to explain the results to the customers. That's very important. Otherwise, they do not trust the model, and that they won't use it if they don't trust the model.
Okay. I haven't thought about explaining results, even though as a consumer, obviously, I'm facing AI in our smartphones and on the web quite often, and they need to gain my trust as a customer as well, right? We got question from Timo Elliott, and actually it is something that I wanted to ask as well. So Timo is saying that it is reported that more than 90% of machine learning projects never go into production. What's your biggest advice to people not to waste time on things that are never used?
Really start with the business value. I mean, like this first discussion with the stakeholders and the business experts, defining success criteria based on business metrics, that's really important. If you can't make a business case out of the machine learning model, you should not attempt it. It's doomed to fail. And this also involves that sometimes when you really think about it, you might come to the conclusion that a clever way of reporting might already be sufficient. And if you look at the costs and the benefit, you might never gain that much with a machine learning model over the simple reporting if you look at the costs. So that's really, really important. So in reality, there are basically like two cases when you can do machine learning. That's either because you can really prove that you help your company to get better results, I mean, either in the top line or in the bottom line, to improve on that. Or second, it could be like a strategic advantage over your competitors. So if you think about like hotel booking sites, of course, there you can spend a lot of time improving the recommendations of hotel rooms, or maybe adding a small assistant that asks you some additional detail. There you can do it because it will give you a strategic advantage over your competitors. But otherwise, you should really go for a business value. If you don't have that, don't do it. Always keep in mind, data scientists are not cheap. The longer they work, the more business value you should get out of it. Otherwise, it won't be sustainable over a midterm horizon.
Thank you, Manuel, for your answer, and thank you, Timo, for asking the question. If anyone else wants to ask the question, please put this in the chat. But actually, you mentioned something about the value of data scientists, but on the other hand, we were discussing that not all models are going into production, right? So how data scientists prove their value to their team, to their companies, right? Because it might happen that you are going through the cycle, but at the end, the model still doesn't perform.
Yeah, that's true. That's true. And here, honesty and transparency is really the key. Really defining the success criteria, and if you put it into production, take care that you have business metrics in place. So then that when some controller comes to you and asks you, okay, why are you spending so much money on data science? Where's the value? You have actually the a possibility to say, okay, look here, we have shown that our, in an A/B test, for example, that our customer engagement, or that the average revenue per customer increases if we apply the machine learning model. So that's really like where you should kind of, take care that, that you can communicate the benefit of your model.
Cool, thank you. And one more question. I don't remember if it was you or Stefan presenting this, but there was about the split of responsibilities between data scientists team and engineering product team. One thing that slightly surprised me is that it is engineering team that is responsible for retraining the model in production. So does it mean that like looking at this model drift is the task of the engineering and product team, and data scientists kind of like hands off, we gave you the model, now you make sure that it keeps the quality over the time?
Okay, maybe I can try to answer. So I think this slide was mainly for particular project, which was this matching of business documents or like a retrainable type use case. And in this kind of use case, the orchestration or the automated training is at least partially on the engineering side, right? Because they set up this framework where the customer uploads the data and so on. And then it eventually passes, of course, to the part that was developed by the data science team that trains the model and so on and collects the metrics. So this is in this particular scenario, right? If you have more the kind of the use case where you can, where the data science team would train the model and ship it, essentially, where you have a universal model that solves many different tasks, or no, there's one task across many different customers. In that case, this responsibility would be with the data scientists, of course, right? But in the other case, it has to be automated. And so that's why, there is I would say joint responsibility, right? Because it's the results of these trainings, these reports, the data scientists will of course look at and try to understand whether the approach works and so on. Yeah, but there's also a lot of engineering aspects in this case, and that's of course where the engineers help. But in general, it's also not so clear cut, right? So there is people who work kind of in between data science and engineering and in the entire spectrum of tasks. So it's not really like 100% clear cut, I would say.
So wearing multiple hats happens even to you. It's like, this is my role today, this is my role tomorrow.
Yeah, I think, exactly. I mean, it's not it's no clear separation.
Okay, there are no more questions in the chat. We are at the top of the hour. Stefan, Manuel, thank you very much for your time. Yes, you wanted to advertise the session?
Yes. So if any questions come to your mind after the session, don't miss the session on November the 4th with our colleagues Sarah, Andreas, and Kartik. They're really experts also in data science in practice. They can answer you all the questions. How do the SAP projects with ML really look like at the customers, etc. So don't miss this session. They're really experts and they love to answer your questions.
Sure. Thank you for sharing this. Okay, with that, I would like to thank everyone who joined. Obviously, the recording will be available for everyone to watch. For those of you who are collecting the Oktoberfest points, please remember that you need to answer validation question, and then your participation in this session will be rewarded with additional badge and additional points. And with that, I'm ending this session. Thank you very much, and see you during next sessions this week and following weeks as well.
Thank you.
Thank you. Yeah.